All right, 6.1 example 2, definitely an uglier looking expression. I am going to use the reciprocal identities from the instructional video. So I am going to replace cotangent x with cos x over sine x, and cosecant x will become 1 over sine x. And what that does to the expression in A here is that we are going to have cos x over sine x, and that's going to be divided, and I'll write that as 1 over sine x times cos x. Now, non-permissible values are from any denominator anywhere, which means that, and the one that most students catch is that sine x cannot be 0. And that's from this denominator and kind of that dotted block. But it's really important that cos x is in a denominator as well, so cos x can't be 0 as well. Now, this is very similar to the non-permissible values from example 1, but this is in radians. So I'm going to go over this really quick, that sine x can't be 0 means that the angles that have a y coordinate are 0 are non-permissible. So x cannot be equal to 0 radians, pi radians, or 2 pi radians. When cos x is 0 is when the x coordinate on the unit circle is 0, so that means that my angle cannot be pi over 2 or 3 pi over 2. That's 90 and 270 respectively. I hope it's valuable maybe to write this as x cannot be equal to 0 pi over 2, 2 pi over 2, and 4 pi over 2. Because then it's a little bit easier to see that we have 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So our angle cannot be any multiple of pi over 2, where n is an integer. All right, that is the same non-permissible value as example 1, except we're doing it in radians instead. Now, to simplify the expression, we've actually done most of the work already. I'm just going to clean it up a little bit, write the numerator as cos x over sine x, and then the denominator would also be cos x over sine x. Now, this is one of those odd situations where I'm dividing an expression by itself. To actually show this, though, I always recommend that we take the numerator and multiply by the reciprocal of the denominator. And I think it's a little more clear to see why the sine x cancels and the cos x cancels. Now, a common mistake in chapter 6 is that students will cancel factors and write a 0. Cos x divided by cos x is 1, and sine x divided by sine x is 1, which means that the simplified version is actually 1 for this question. It's a little bit odd that it simplifies into a constant. What's very important to remember that I can't plug pi over 2 or pi or 2 pi over 2 or 3 pi over 2 or any multiple of pi over 2. So this is equal to 1 for any permissible value of the angle.